Hello and welcome to algebra. All right, so today we're going to learn about transformations. All right, so transformations, think transformers. It means things are going to change, right? Okay, so the first thing we got to learn is the most basic linear equation is y equals x. And this is called the parent function. And it's the most basic because it's just a simple equation. It's y equals x. It's whatever y is, x is the same thing, right? So if I was looking at this in y equals mx plus b form, I can tell that my y-intercept is 0 because nothing's being added to it, right? And my slope is 1 because the number in front of a variable, even if it's not written, is always 1, right? So that's my equation. So if I was going to graph this, I would start on 0 on my y, and then I would go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, until I got my line, right? So that's our most basic equation. It's called the parent function, y equals x. Okay, so if we ever change the slope or we change the y-intercept, that's going to transform the graph. It's going to change how this line looks. All right, so let's do some examples together and try and figure this thing out. All right, it says graph the following lines on the coordinate grid. So we got three different equations. If you have colored pencils, try and use two different colored pencils, and you can use like your regular pencil for this first one. It says in pencil, and let's graph it. So the first one is our parent function. So remember that parent function means that y equals x. That means my y-intercept 0, and my slope is 1, right? So up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And then I can draw my line, right? It'll be something like that. Okay, so that is my parent function. I'm going to put that in blue so you can see it. All right, so let's do our next line. Our next line says y equals x plus 3. So x plus 3, let's graph that. So plus 3 means my y-intercept is 3. So I'll put a dot on 3. And my slope is still 1 for this one. So up 1 over 1, up 1 over 1, up 1 over 1. After I get some points, I can connect my dots and I can make my line. All right, let's try, and we did that one in pink, right? So let's put a pink next to that. All right, let's get another color. Let's do green. Okay, so the next one says y equals x minus 3. So x minus 3 means my y-intercept is at negative 3 because it says minus 3. And then my slope is still the same, still a 1 in front of that x. So it's up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, right? After I get some points, I can connect my dots and make my line, right? All right, there we go. All right, so what do we notice? What happened after the first transformation? Well, this is where it started. It looks like it was slid up, right? So it slid up. What happened after the second transformation? Well, the blue line is where we started, the parent function. That green line, it looks like it slid down. All right, so what is changing in the equation? So if I look at my equations over here, y equals x is my parent function. This is y equals x plus 3, y equals x minus 3. What is changing? Well, the slope is staying the same. The y-intercept is changing. They added 3 to slide it up. On the next one, they minus 3 to slide it down. So what's changing is the y-intercept. The y-intercept is changing. All right, so what we can say is when we change the y-intercept, it translates the graph up or down. Right? So if I add something, it's going to move it, slide it, or translate it. Translating means that you're moving it. You're going to move it up. If I put it at minus 3 or minus 2 or minus 5, right, anything like that, it's going to slide it down. It's going to translate it down. So when your y-intercept changes, it's translating. All right, let's try this next thing. All right, so this next one, we're going to graph both of these in the same thing, and we're going to see what happens to it. All right, so this first one says y equals 3x plus 1. So 1 is my y-intercept, so I'm going to start on 1. And then my slope is 3, so that means up 3 over 1. Up 3 over 1. And after I get some points, I can connect my dots and make my line. Right? There we go. All right, so now let's change colors here. Let's put blue next to this so we remember that's blue. And let's change colors. I like the pink color. It looks just so nice, doesn't it? Okay, so y equals negative 3x plus 1. So that means I'm going to start at 1 again. So I'm going to put a dot on 1. And now my slope is negative 3. So it means I'm going to go down 3, 1, 2, 3, over 1. down 3, 1, 2, 3, over 1. And I got my points on my line, or my graph, so now I can connect them and make my line. Right? All right, so that's not a very straight line. Let's see if I can do this better. There we go, it's a little bit better. All right, so what do we notice about these two lines? What happened to it? Well, it looks like it's flipped over this y-axis here, right? So what happened to the line? It flipped over the y-axis. What is changing in the equation? So let's look at these equations. The y-intercept's the same, but the slope changed. The sign of the slope changed. The sign of the slope changed. The first one was a positive 3. The bottom one's a negative 3. Right? So what can we conclude? Well, we can conclude if we change the sign of the slope, we reflect the line over the y-axis. So if you change the sign of the slope, if it's positive and you make it negative, it's going to reflect that line over the y-axis, right? And that is called reflection. When you change the sign of the slope, it's called reflection. All right, it's got one more here. It says, graph the following on this plane. Let's see, the first one says y equals 4x minus 1. So minus 1 was where I'll start. 4x means my slope is 4, so I have to go up 4, 1, 2, 3, 4, over 1. Up 4, 1, 2, 3, 4, over 1. And after I get some points, I can make my line, right? Connect my dots, make my line. Boom, done. All right, let's do the next one. Let's see what happens to that line. Let's see here. So now I got 2x minus 1, right? So I'm going to still start at minus 1, and now it says 2x. That means up 2 over 1. Up 2 over 1. Up 2 over 1. I got a bunch of points there, so now I can connect my dots and make my line. There we go. All right, and then I got one more I can do. I got this one here. It says y equals 1/2 x minus 1. So I'm still going to start at minus 1. And 1/2 means up 1 over 2. Up 1 over 2. Up 1 over 2. All right, I got my points, so now I can connect my dots and make my line. All right, cool. So what happened to the first transformation? Well, the pink was my first line, and then it got this blue line, right? So what happened to it? Well, it became less steep, right? That pink line's pretty close to being straight up and down. That's a pretty steep line. Imagine like sledding down that hill. That'd be a pretty fun hill to slide down. Right? What happened to the second transformation? It became even more less steep, right? So what's changing in the equation? Well, the y-intercept was the same for all these. The only thing that changed was the slope. The slope changed. So when we change the slope, it dilates the line. Another way of saying dilate is it changes the steepness of the line. Okay? It changes the steepness of the line. If you ever change a slope, any big number is going to make the slope more steep. Any small number is going to make the slope less steep. And you can see that here, right? Like 4 is pretty steep here. That pink line is pretty steep, right? Where if you see like a half, that is less steep. It's a lot more flat, right? So in general, if anything's bigger than 1, if your slope is bigger than 1, it's going to be more steep. If it's less than 1, it's going to be less steep. Okay? All right, so that is called dilating or changing the steepness of a line. All right, so let's review this real quick. All right, so translating, what does that mean? Well, translating means that we are moving the line up or down. All right, and we looked at that, right? So the parent function is y equals x. If this is y equals x plus 2, that means we're going to be translating it. That means it's going to be going up 2 units, right? So that means that y-intercept's getting slid up, right? All right, the next thing we did was reflection, right? So reflection is a mirror image over the y-axis, all right? That's what it means. What's the equation look like? Well, the parent function is still y equals x, and if we were going to do a reflection, we change the sign of the slope. So this is a positive 1 slope in the parent function, so a reflection of that would be a negative 1x, right? So that is reflection, reflects over the y-axis. All right, and the last thing we did was dilation, right? Dilation, it changes the steepness of the line. So if the parent function is y equals x, and I had this one that says y equals 4x, that means that is greater than 1. That's a greater than sign. Greater than 1, it's going to make it more steep, right? If I had one that said y equals a half x, that is less than 1. That's a less than sign there, less than 1, and that means it's going to make it less steep. Okay? So translate means you're going to move it up or down, you're going to shift it up and down. Reflecting means it's going to reflect it over the y-axis, and dilate changes the steepness of the line. All right, so I wrote some examples here for you. Go ahead and graph them on your graphs over here so you can have a nice quick reminder of what they look like. And if you ever have any questions on translating, please ask a teacher. And I'll see you next time. All right, later.